Did you know that China has been leading the battery game for years, with the US and Europe trying hard to catch up? Most electric vehicles in the US still depend on batteries made in China. That's just the plain truth. But wait a moment, because something exciting is unfolding. A US-based company has just unveiled a battery that's shaking up the entire industry. It's not solid-state, and it's not your typical lithium battery either. It goes beyond both, offering benefits that have truly amazed experts. This new battery lasts longer, works perfectly in freezing temperatures, charges incredibly fast, and packs a record-setting energy density of 660 watt-hours per kilogram. What does that mean for you? An electric car could drive as far as 1,000 miles on just one charge. And Tesla might get its hands on this soon, since the battery is being produced right here in the US. Not speculation, but actual fact. Sandy Munro, a top expert in EVs and battery tech and a well-known figure in the car world, saw it in person at the plant and couldn't stop praising it. Right after Sandy's video, the company even received a global award for its game-changing innovation. Could the US actually beat China in the battery race? Maybe not right now, but looking ahead, we believe it just might happen. So, what exactly makes this new battery technology so special? And will it really show up in Tesla EVs anytime soon? Let's not keep you waiting. Here's the reveal. The game-changing battery we're talking about is the semi-solid lithium-ion battery developed by a company called 24M. The name 24M stands for 24 Molecular, and they're based in Cambridge, Massachusetts, USA. Known for pushing boundaries in battery tech, 24M has focused on solving big industry problems like high costs, safety risks, low energy density, and recycling challenges. What sets 24M apart is their use of lean manufacturing principles. Regular lithium-ion batteries are made with complicated winding techniques and strict layering of anode, cathode, and separator materials, processes that can easily go wrong, causing issues like dendrites and short circuits. 24M simplifies all that using a special semi-solid method called LiFB, lithium-ion flow battery, sometimes nicknamed Live Forever. Instead of using binders or building in layers, 24M blends the electrolyte right into the active material, turning it into a thick paste. Then they spread this slurry directly onto metal foils. That clever change cuts the number of production steps in half, slashes factory costs, reduces energy use, and lets them build thicker, more powerful electrodes. And the results? A battery that's safer, greener, and way more energy-packed. Lab tests have shown it can hit energy densities of 660 watt-hours per kilogram, blowing past the 400 watt-hours per kilogram mark that's considered a major milestone for things like electric planes, top-tier EVs, and even flying taxis, EVTOLs. The higher the energy density, the lighter the battery, and the farther and faster you can go for less money. Now, you've probably heard of solid-state batteries, right? In simple terms, solid-state batteries use a solid material in the middle instead of the usual liquid electrolyte found in lithium-ion batteries. That middle layer, called the electrolyte, is what lets energy-carrying ions travel between the two ends of the battery as it charges and discharges. To put it even more simply, if a lithium-ion battery is like a sandwich with sauce in the middle, then a solid-state battery is like a sandwich filled with meat instead. But 24M's battery isn't solid-state, and yet it's insanely fast. How fast? It can add 200 miles of range in just 4 minutes. Seriously. And here's the kicker. It doesn't even need expensive, high-power megawatt charging stations to do that. 24M says their tech works great with the standard 400 volts or 800 volts chargers, which makes it even better than what BYD offers, because it's already compatible with existing infrastructure. With 660 watt-hours per kilogram, going 1,000 miles on a single charge is no longer just a dream. In fact, CATL in China already made a battery with 500 watt-hours per kilogram and proved 1,000 miles is totally possible. Why does that 1,000-mile figure matter? Because it's more than most people ever need in a day. It means you could take a road trip across several states without having to stop for a recharge. For comparison, most gas cars only go 400 to 600 miles per tank, so this would actually make EVs more convenient than traditional vehicles. And that 4-minute charge for 200 miles? That changes everything. It erases one of the biggest reasons people hesitate to go electric: waiting forever to charge. This tech crushes that problem. When we saw what this battery could do, we couldn't help but think, why hasn't anyone done this before? No wonder it just took home the Best Technology of the Year award. While the solid electrolyte in solid-state batteries is seen as a revolutionary replacement for liquid electrolytes, enabling higher energy density, it comes at a cost. Solid-state batteries are still very expensive, and battery degradation remains a major challenge. That's why 24M has taken a different approach, using a new type of electrolyte called Eternality, which enables faster charging and significantly improves performance in cold conditions. Yeah, 24 million can't reveal too much about this Eternality electrolyte, since it's a proprietary technology, and exposing too many details could lead to it being stolen at any moment. However, according to publicly available reports, this proprietary solvent dramatically improves low-temperature performance. In testing at -40 degrees Celsius, 24 million cells retained full power and energy transfer, outperforming conventional electrolytes, which freeze or lose conductivity at those temperatures. As we all know, when temperatures drop to -20 degrees Celsius, traditional lithium batteries perform very poorly. Standard batteries can lose 25 to 30% of their capacity at 0 degrees Celsius, especially lithium iron phosphate types. Eternality, on the other hand, retains nearly full capacity at 0 degrees Celsius and maintains over 80% even at -40 degrees Celsius, something that's almost unheard of. Eternality shows virtually no weaknesses. This electrolyte has 3 times the ionic conductivity of standard materials, allowing ions to move faster between the anode and cathode, resulting in charging speeds up to 4 times faster. For EV markets in cold climates and military applications, where extreme temperature resilience is vital, this is a huge advantage. The CEO of 24M said, "Eternality solves some of the biggest challenges facing lithium batteries today." But here's the key point we haven't mentioned yet. This electrolyte can be used not just in one type of battery, but across a wide range of lithium-based batteries. Whether it's Tesla's 4,680 cells or batteries using silicon or graphite, as long as it's lithium-based, you can use Eternality to instantly boost energy density. According to 24 million, integrating this electrolyte into existing manufacturing lines isn't difficult. And when combined with the company's Impervio separator, it offers unmatched safety and battery longevity. Speaking of the Impervio separator, it's the very product that just won Fast Company's 2025 World-Changing Ideas Award. Here's an easy way to understand it. 24M's Impervio separator is a breakthrough in battery fire safety, designed to address key risks like overcharging and internal shorts, the main causes of thermal runaway that lead to fires and costly recalls. By actively suppressing dendrites and enabling early fault detection, Impervio can prevent thermal incidents before they start. It enables next-generation lithium-ion and lithium metal batteries to deliver enhanced performance and safety without sacrificing manufacturability. Across EVs, energy storage systems, consumer electronics, aviation, e-bikes, and more, Impervio separators add an embedded conductive layer between insulating layers. This actively suppresses dendrite growth and acts like a circuit breaker at the cell level. The separator in this battery can spot early signs of internal shorts and alert the battery management system, which then isolates and safely discharges any affected cells before they become a problem. The batteries that will drive our cars in 2030? They're being developed in today's labs. No one can say for sure who will win the race to create the next generation of batteries. But if you guessed 24 million, we wouldn't be surprised one bit. This company is stacked with top-tier talent from every level. Right now, cell-to-pack is all the buzz. But 24M's approach, called Electrode-to-pack, is even more efficient. In fact, it improves battery construction by at least 10 times compared to current methods. It's another huge leap in smart, lean design. Their concept uses carpet cells, massive sealed electrode sheets layered with polymers and separators. Instead of squeezing hundreds or thousands of tiny cylindrical or pouch cells into a battery pack, they replace them with just a few big carpet cells. Imagine swapping 300 small cells in an EV for just 6 large ones. That slashes packaging needs, cuts down on wiring and bus bars, and boosts both energy density and space efficiency. Fewer parts also mean fewer things that can go wrong, plus a simpler battery pack overall. The production of these carpet cells is already semi-automated and can scale up fast. And with this streamlined setup, the cost benefits are clear. Up to 30% lower cost per kilowatt-hour compared to traditional designs. That's huge, especially when the goal is to drop below $100 per kilowatt-hour. The magic number for making EVs truly affordable. With the $7,500 federal EV tax credit now tied to batteries that don't include Chinese-sourced materials, Tesla is feeling the pressure to find alternative battery technologies. It's the only way to keep vehicles like the Model Y, Model 3, and Cybertruck eligible for these incentives. There's a temporary allowance until 2027 that lets companies still use graphite from China. But Elon Musk isn't sitting still. He's already all in on domestic battery tech, including Tesla's own 4680 cells. So if 24M's technology keeps gaining momentum, you can bet Musk will be paying very close attention. And when it comes to battery recycling, a major choke point for the industry, 24M offers a much cleaner path forward. Thanks to their sealed electrode design, which doesn't rely on binders, the battery materials can be separated mechanically. There's no need for the harsh, expensive methods like pyrometallurgy or hydrometallurgy. Based on everything we know, the Live Forever technology allows up to 98% of materials to be recycled. And it does this without creating black mass, making it way more eco-friendly. That not only simplifies recycling, but helps build a true closed-loop battery system, which is key as EVs go mainstream. As of mid-2025, 24 million has completed a 140,000 square foot facility near Cambridge, Massachusetts. They're now scaling up toward a production capacity of 200 megawatt-hours per year. The company is actively working with car makers and defense contractors to bring their advanced batteries to market. Their leadership team says the production ramp could begin before the year ends, a schedule made possible by strong investor backing and serious interest from industry partners. In short, 24M Technologies is offering a rare leap forward in battery design, one that tackles energy density, safety, ease of manufacturing, and recyclability all at once. For EV engineers, it's a breakthrough that could help increase range, cut costs, and simplify battery systems. For investors and automakers, it's a strategic chance to get ahead in the race to compete with Chinese battery giants. And for EV fans, it means better performing batteries that hold up in even the harshest real-world conditions. Switching to other news about Tesla Robotaxi. As we all know, Tesla's self-driving taxis have officially launched operations in Austin, Texas. While the service is currently limited to a small group of influencers and early testers, it's expected to roll out to the general public on a much larger scale by the end of this year and into next year. The introductory fare is just $4.20 per ride. Tesla's robo-taxi service kicked off with a modest fleet of around a dozen Tesla Model Y vehicles, operating within a 15 to 20 square mile area in South Austin. Users can book a ride from 6 a.m. to midnight using the Tesla app on their smartphones, following a process similar to other ride-hailing apps like Uber or Lyft. The fleet is expected to expand significantly as the service enters full-scale deployment. Unlike traditional ride services, Tesla's robo-taxi offers a unique experience. Passengers are greeted with onboard music and preloaded video entertainment, as well as the ability to adjust the cabin temperature to their personal preference. Notably, during the testing phase, there are no drivers, only a Tesla safety operator sitting in the front seat to ensure safety. However, their role appears mostly observational, with minimal interaction with passengers. If an emergency stop is needed, passengers can contact a remote Tesla operator, while the in-vehicle supervisor remains passive. In its early days of operation, Tesla's robo-taxi has demonstrated impressive performance. It has successfully navigated heavy traffic, avoided wildlife, and maneuvered through tight parking lots in Texas. That said, a few noteworthy behaviors have been observed. For instance, the vehicles have occasionally exceeded the speed limit by a few miles per hour to keep up with traffic flow. Technically a violation, though not dangerous. In other cases, the car briefly drifted into the wrong lane, although it fortunately escaped police notice. These Model Y vehicles use a customized version of Tesla's full self-driving software, but they are essentially standard cars, marked only with robo-taxi logos on the sides and rear. Their driving behavior closely mimics that of a human, taking advantage of gaps in traffic to pass, or making slight natural steering corrections. This demonstrates how far Tesla's full self-driving technology has progressed, offering a ride experience that feels surprisingly human-like. One major difference compared to services like Uber is that passengers don't need to pay attention to the road. Thanks to full self-driving capabilities, they can freely check emails, watch videos, or play games on the in-car entertainment system. In fact, the upcoming Cybercab is what Tesla considers a real robo-taxi, a two-seater with no steering wheel, no pedals, extra storage space, and even an onboard self-cleaning robot system. It's expected to be priced under $30,000, with mass production starting next year. The Cybercab is poised to redefine the future of robo-taxis. In the meantime, the Model Y is leading the charge. Tesla has stated that any vehicle equipped with full self-driving could eventually join the robo-taxi network, unlocking massive potential for the millions of Teslas already on the road worldwide. Tesla's self-driving technology is powered by a neural network trained on millions of hours of driving data collected from Tesla users. Instead of hard-coding responses to every possible scenario, the system allows the car to think and react like a human, using 9 continuous camera feeds. This vision-only approach sets Tesla apart from competitors like Waymo, which relies on radar and LiDAR sensors to gather data. Although both systems have made significant advancements, Waymo currently leads in scale, with around 1,500 vehicles operating across multiple cities, including Austin. Waymo plans to double that number by the end of 2026. However, each Waymo vehicle costs roughly $150,000 to produce, compared to under $40,000 for a Model Y, giving Tesla a major economic advantage in the robo-taxi race. Tesla's robo-taxi service isn't just a bold tech breakthrough, it's also shaping up to be a highly profitable business model. With millions of Teslas already on the road, the company can quickly expand its robo-taxi fleet without sinking massive money into building new cars. Add to that the relatively affordable Model Y, which undercuts pricier rivals like Waymo, and Tesla gains a major edge on cost. But it's not all smooth sailing. Even small issues, like a vehicle going slightly over the speed limit or drifting within a lane, could lead to legal headaches and chip away at public trust. Plus, Tesla still faces the enormous challenge of making its self-driving system flawless in every situation, without any need for human input, a benchmark that even Waymo hasn't hit yet. As we wrap up today's episode, here's what's truly exciting for anyone who believes in the EV revolution and the shift to fully electric transportation. New battery technology that makes long-distance driving possible with ultra-fast charging. The tech from 24 million might be just what the industry needs to turn that vision into reality. Right now, 24M's batteries still need to pass real-world testing by automakers, especially in extreme weather conditions, both hot and cold. But with this recent breakthrough, it feels like the company is giving us a glimpse into the next era of EVs. If this tech can eliminate range anxiety, it could deliver a massive boost to electric cars and trucks. The future of EVs isn't just on the horizon anymore. It may already be unfolding before our eyes, thanks to 24E. So here's the big question. How do you see 24M's semi-solid battery, with its potential 1,000-mile range and 4-minute charge time, changing the game for the EV industry? Could this be the moment that helps the US catch up to China in the battery technology race?